Our last piece to Unit 6 and our entire focus for this entire week is on experimental probability. What we're going to be doing in class all this week is doing various activities that really focus on tying everything together with this idea of experimental probability as we round out our probability unit. So first we need to define experimental probability. And experimental probability is what actually happens. We're still setting it up of total possible on the bottom, what we want on top, but this time when we talk about total possible, that's the total number of trials or experiments that has occurred. So let's take a look at Part A. Part A, we have a table that shows the results of spinning a spinner 50 times. So we want to find the experimental probabilities of spinning a 4 and a spin greater than 2. Well, the nice part is that our directions tell us that we spun it 50 times, which means that my denominator is going to be 50. And spinning a 4 means we're going to be taking a look at the table at 4. And it says that 4 was spun 14 times, so we have a 14 here. Well, 14 out of 50, we can double that to get out of 100, so that's 0.28, and that is equal to 28%. A spin greater than 2, well, that is going to be anything above 2, which is here. So what we're going to do is we're going to take 19 plus 14, which gives us 33 out of 50, which if we divide 33 by 50, we get 0.66, which is 66%. The next example, we have a table showing the results of choosing one card from a deck of cards, recording the suit, and then replacing the card. And find the following experimental probabilities. So probability of a diamond. Well, it says here, diamond was 9 times, and we need to know that how many it was totally out of. So we have 5 plus 9, which is 14, plus 7, which is 21, plus 5 is 26. Now if we take a calculator and we do 9 divided by 26, we get approximately equal to 0.346, so that would be equal to 34.6%. Probability of not a club, that means we don't want clubs in here. So it's everything but that. So I have here that I want hearts, diamonds, and spades. Well, 5 plus 5 is 10, plus 9 is 19. Still out of 26. If we take 19 divided by 26, we get equal to 0.7307 or 731, which is equal to 73.1%. Moving on to the next example, we have a 52% chance that your team will win the game today. What is the chance that your team will not win? Well, we know that in probability, either you're going to win or you aren't going to win. And winning and not winning together adds up to 100%. Well, if I subtract my 52% chance of winning, I'm going to get the percent chance that we will not win. And 100 minus 52 is 48%. In a particular problem like this, giving me the probability just as a percent is okay. You could also simplify it down to 12 out of 25 or 0.48. We're not going to get too picky like that just because if it gives you as a percent, we'll leave it as a percent. Now we've got Zach. He usually makes 13 out of 20 shots he takes on net on the hockey goal. What's the probability that he will miss his next shot? Well, 13 out of 20 is the probability that he will make it. We want what if he won't make it, we're going to subtract 1 from that. Well, 100% would be 20 out of 20. Minus 13 out of 20 is going to be 7 out of 20, which is equal to 0.35, which is equal to 35%. Our final example, we have Isaac. Isaac rolled the number cube 100 times and the number 5 came up 19 times. Well, here it says, what's the theoretical probability of rolling a 5? Well, I know when I have a number cube, I have 6 possible outcomes. My sample space is 1, 2, 3, 4, 5, 6. And rolling a 5, that's one of them, so 1 out of 6 chance, which is 0.167 or 16.7%. Now we want the experimental probability. Well, it says that we rolled 100 times. Isaac rolled 100 times, 19 times it came up a 5, which is 0.19, which is equal to 19%. Now, we need to predict what would happen if, with the experimental probability, if he rolled that number cube 100 more times. And the thing about what theoretical probability, which is what should happen, and experimental probability of what actually happens, is that they should be relatively close. But remember, our world isn't perfect, so it's not a guarantee. So one of the things that we know is that the more trials you do, the closer you're going to get to our actual theoretical. So 100 more times, we could say that the experimental probability will get closer to the 16.7% theoretical probability. Because the more you do, so if we did 100 more and then 100 more after that, eventually we'll get to the point where it'll be so close to that 16.7% that we're practically at our theoretical probability. Your job now is to go ahead and give these two U-try problems a shot. One dealing with another spinner experiment, this time with colors, and then another card experiment and calculating those the experimental probabilities. And as always, bring your questions with you to class tomorrow.